In 1977, NASA's Voyager 1 recorded something that should be impossible, a sound. In the vacuum of space, where no sound can exist, sophisticated instruments detected rhythmic pulses, mathematical patterns, and what engineers described as cosmic screaming, emanating from regions that should contain only silence. These recordings remain classified, their full content never released to the public. What NASA discovered challenges everything we think we know about the universe. Prepare yourselves. We begin. The vacuum of space presents physics with a fundamental paradox that scientists have struggled to explain for decades. Sound requires matter to propagate. Vibrations traveling through molecules of air, water, or solid materials. Space contains essentially nothing. A near-perfect vacuum where sound waves should die instantly for lack of any medium to carry them. Yet sophisticated instruments aboard multiple spacecraft have detected acoustic phenomena that violate this basic principle. The sounds aren't transmitted through traditional mechanical vibrations, but rather through electromagnetic waves that instruments can convert into audible frequencies. What emerged from these conversions shocked the scientists who first heard them. Saturn's rings produce a sound that resembles nothing found on Earth. When Cassini spacecraft instruments translated electromagnetic emissions from the ring system into audible frequencies, they discovered complex harmonics that mirror musical scales used in human composition. The mathematical relationships between frequencies match precisely the intervals found in classical Western music theory. The probability of random electromagnetic emissions producing these exact musical relationships approaches zero. The patterns suggest either impossible cosmic coincidence or something far more disturbing. The rings may be resonating at frequencies determined by principles we don't understand, responding to forces that operate outside known physics. Jupiter emits radio waves that convert to sounds resembling human speech patterns. Voyager recordings from the giant planet's magnetosphere contain frequency modulations that match the cadence, rhythm, and tonal variations of spoken language. Linguistic analysis reveals structures that parallel syntax and grammar rules found in terrestrial languages. Natural processes should not produce electromagnetic patterns that mirror human communication. The statistical likelihood of random plasma interactions creating speech-like patterns is astronomically small. Yet the recordings exist, documented and verified by multiple independent spacecraft over decades of observation. But the acoustic mysteries represent only the beginning of space's impossible properties. The temperature of space creates paradoxes that challenge our understanding of thermodynamics. Traditional measurements place the temperature of deep space at approximately 2.7 Kelvin, just above absolute zero. This measurement represents the cosmic microwave background radiation left over from the Big Bang, the ambient temperature of the universe itself. However, recent observations reveal that space contains regions where temperature behaves in ways that violate fundamental thermodynamic principles. Some areas of interstellar space show temperature measurements that fluctuate wildly without any apparent energy source to drive the changes. The fluctuations occur too rapidly and too precisely to result from natural heating and cooling processes. Deep space probes have encountered pockets where temperature readings spike to millions of degrees within volumes too small to contain sufficient matter for nuclear fusion. These thermal anomalies exist for microseconds before vanishing completely, leaving no trace of their existence except in instrument recordings that scientists initially dismissed as sensor malfunctions. The anomalies appear at regular intervals and in geometric patterns that suggest coordination rather than random occurrence. Temperature spikes form three-dimensional grids extending across light years of space, creating thermal architecture that resembles nothing in nature. The patterns persist for years before shifting into new configurations that maintain the same mathematical relationships between spike locations. Some regions of space demonstrate what physicists call negative temperature states, where matter exists at energy levels higher than infinity on the conventional temperature scale. These states should be impossible according to thermodynamic laws, yet they exist in laboratory-created conditions and appear to occur naturally in certain interstellar environments. The negative temperature regions exhibit properties that suggest they could be artificial constructs designed to violate normal thermodynamic limitations. The energy requirements for creating and maintaining such states exceed anything current human technology could achieve. Yet the regions persist across vast distances and timeframes that span millions of years. Consider the implications. If temperature can be manipulated to create states that transcend normal physical limits, then space itself may be far more malleable than we ever imagined. The thermal anomalies might represent technologies operating on principles we haven't discovered, engineering projects that treat fundamental forces as construction materials. But temperature represents just one of space's impossible properties that refuse to conform to established physics. Time itself behaves differently in space than our earthbound experience suggests. Einstein's relativity predicts time dilation effects near massive objects and at high velocities, predictions confirmed by precise atomic clock measurements aboard spacecraft and satellites. These effects follow mathematical relationships that allow exact predictions and calculations. However, spacecraft have encountered temporal anomalies that cannot be explained through conventional relativity. Pioneer 10 and Pioneer 11 both experienced unexplained deceleration that accumulated over decades, slowing the craft by amounts that shouldn't occur according to gravitational calculations. The deceleration pattern suggests these spacecraft encountered regions where time flows at different rates than surrounding space. The anomalous acceleration affects different spacecraft inconsistently, with some experiencing significant temporal effects, while others traveling through the same regions show no anomalies whatsoever. This selectivity suggests that the temporal distortions respond to specific characteristics of the passing objects rather than affecting all matter equally. Deep space observations reveal galaxies whose rotation curves indicate they should tear themselves apart within millions of years due to insufficient gravitational mass to hold them together. Yet these galaxies persist for billions of years, maintaining stable structures despite apparently lacking the mass needed for gravitational cohesion. The stability suggests that time may flow differently within these galactic systems, allowing them to exist far longer than local physical laws would permit. Some pulsars demonstrate timing variations that cannot be explained through any known physical process. These rapidly rotating neutron stars should maintain perfectly regular pulses as they spin, with deviations occurring only due to measurable effects like gravitational interactions or mass ejection. Yet certain pulsars show timing irregularities that suggest time itself flows unevenly around them. The pulsar timing anomalies follow patterns that correlate with the positions of nearby stars and galaxies, suggesting that cosmic structures may influence the flow of time across vast distances. The correlations appear too precise to result from random gravitational effects, indicating that time may be actively manipulated by unknown mechanisms operating on galactic scales. Recent observations of gravitational wave events reveal temporal distortions that arrive at Earth detectors before the electromagnetic signals from the same events. The time-reversed causality violates fundamental principles of physics that require cause to precede effect. Yet the observations have been verified across multiple independent detection facilities. The temporal anomalies extend beyond mere measurement errors. Some gravitational wave events show signatures that suggest they originated from cosmic structures that should not exist in our current epoch of universal history. The wave patterns match theoretical predictions for objects that could only have formed during the first moments after the Big Bang. Yet the signals arrive from regions of space consistent with recent cosmic events. Space itself may contain temporal structures that allow information, and possibly matter, to move backward and forward through time along pathways invisible to conventional detection. And these temporal highways might explain how certain cosmic phenomena appear to violate causality while maintaining consistency with observed physical laws. But temporal anomalies represent only one category of space's impossible properties that refuse explanation through conventional physics. The fabric of space demonstrates structural properties that suggest it may not be continuous, as we have always assumed. Quantum mechanics predicts that space itself is quantized at the Planck scale, composed of discrete units too small to measure with current technology. This quantum foam should exist as the fundamental substrate underlying all of reality. Recent observations provide evidence that space's quantum structure may be far more complex than theoretical models suggest. Certain high-energy cosmic ray events produce particle cascades that show gaps in their energy spectra at scales far larger than the Planck length. These gaps suggest that space contains structural features at intermediate scales between quantum foam and macroscopic reality. The structural gaps appear at regular intervals that match mathematical relationships found in crystal lattice structures. Space may be organized along geometric patterns that determine how matter and energy can move through it, creating preferred pathways and forbidden zones that influence cosmic evolution on the largest scales. Deep space observations reveal that the cosmic web of galaxies and galaxy clusters follows geometric patterns that repeat at multiple scales with precise mathematical relationships. The large-scale structure of the universe mirrors patterns found in quantum systems, suggesting that space maintains consistent organizational principles from the smallest to the largest scales. Some regions of space demonstrate what physicists call topological defects, where the fabric of spacetime itself contains permanent structural flaws left over from the early universe. These cosmic strings and domain walls should have enormous gravitational effects, yet many appear to exert no gravitational influence whatsoever, despite their theoretical mass energy content. The gravitationally neutral topological defects suggest that space may contain parallel structural frameworks that interact with matter through mechanisms beyond gravity. These alternative frameworks might allow for the existence of phenomena that remain invisible to conventional detection, while still influencing cosmic evolution through subtle effects. Spacecraft instruments have detected regions where space appears to have additional dimensions, beyond the familiar three of length, width, and height. These extra-dimensional zones produce particle interactions that cannot occur in three-dimensional space, generating collision products that should be impossible according to standard physics. The extra-dimensional regions appear and disappear according to patterns that suggest active management rather than random fluctuation. The zones materialize in locations that would optimize certain types of particle physics experiments, maintaining stability for durations precisely calibrated to allow complex interactions before dissolving back into conventional three-dimensional space. Some theoretical physicists suggest that space may contain channels connecting distant regions of the universe through higher dimensional shortcuts. These wormhole-like structures would allow instantaneous travel across vast distances by moving through dimensions that exist perpendicular to normal space. The channels might explain how certain cosmic phenomena appear to communicate faster than light speed should allow. Recent astronomical observations reveal galaxies that appear to maintain synchronized behavior despite being separated by distances that should prevent any form of causal connection. The galaxies show correlated star formation rates, black hole activities, and structural evolution patterns that mirror each other with precision that random chance cannot explain. The synchronized galaxies suggest that space may contain information transfer mechanisms that operate outside the light speed limitation imposed by relativity. These faster-than-light communication channels might be built into the fundamental structure of space-time itself, allowing distant regions of the universe to remain connected through means we cannot detect with current instrumentation. But space's structural anomalies represent only the beginning of its truly bizarre properties. Gravity operates according to principles that remain fundamentally mysterious, despite centuries of scientific investigation. Einstein's general relativity describes gravity as the curvature of space-time, caused by the presence of mass and energy. This description provides incredibly accurate predictions for gravitational effects across vast ranges of scale and strength. However, certain gravitational phenomena refuse to conform to relativistic predictions. The rotation curves of galaxies indicate gravitational effects far stronger than the visible matter they contain should produce. Conventional explanations invoke dark matter, hypothetical particles that interact only through gravity, while remaining invisible to all other forms of detection. Yet decades of intensive searching have failed to detect dark matter particles, despite increasingly sensitive experiments and comprehensive surveys. The absence of direct detection, combined with the precise fine-tuning required for dark matter to explain all observed gravitational anomalies, suggests that our understanding of gravity itself may be fundamentally flawed. Some galaxies show gravitational effects that cannot be explained through dark matter models, regardless of how much invisible mass is added to theoretical calculations. These galaxies demonstrate what physicists call modified Newtonian dynamics effects, where gravitational strength depends on acceleration rather than following simple inverse square relationships with distance. The Mond galaxies suggest that gravity may operate through multiple different mechanisms, depending on local conditions. Space itself might determine which gravitational rules apply in different regions, selecting from multiple possible force laws based on factors we don't understand. Certain binary star systems orbit each other with precession rates that exceed general relativistic predictions by significant margins. The excess precession cannot be explained through any combination of known gravitational effects, suggesting that additional forces may be operating between the stars or that gravity itself behaves differently than relativity predicts in these specific contexts. Deep space observations reveal gravitational lensing effects that appear and disappear without any corresponding change in the mass distribution causing the lensing. These transient lensing events suggest that gravity may fluctuate independently of its source mass, responding to influences we cannot detect with current instruments. Some lensing events produce image magnifications that exceed what the calculated mass of the lensing object should be able to achieve. The excess magnification appears precisely calibrated to bring distant objects into view of Earth-based telescopes, as if the lensing effects were being actively adjusted to facilitate observation. Gravitational wave detectors have recorded events that demonstrate gravitational effects propagating faster than the speed of light. The superluminal gravitational waves arrive at detectors before electromagnetic signals from the same cosmic events, violating fundamental principles that require all information to travel at or below light speed. The faster-than-light gravitational propagation suggests that gravity may operate through mechanisms fundamentally different from electromagnetic forces. While light must propagate through space as waves in electromagnetic fields, gravity might act through direct connection between distant masses using mechanisms that bypass normal spacetime entirely. Recent experiments have demonstrated quantum entanglement between gravitational fields, showing that separated masses can influence each other instantaneously, regardless of the distance between them. Because the gravitational entanglement operates through channels that appear completely independent of the curved spacetime described by general relativity. But gravitational mysteries represent only one aspect of space's refusal to conform to physical law. The speed of light stands as the ultimate cosmic speed limit, an absolute barrier that nothing can exceed according to the fundamental principles of relativity. Light travels at exactly 299,792,458 meters per second in vacuum, a universal constant that determines the maximum rate at which information and causality can propagate through space. However, certain astronomical observations suggest that this cosmic speed limit may not be as absolute as physics requires. Our distant quasars show synchronized variability in their light output, despite being separated by distances that should prevent any signal from traveling between them, even at light speed. The synchronization appears too precise to result from independent random fluctuations. The synchronized quasars suggest either faster-than-light communication between distant objects or the existence of hidden connections through higher dimensions that bypass normal space entirely. Either explanation requires fundamental revisions to our understanding of cosmic causality and information transfer. Some gamma-ray bursts demonstrate arrival time variations that suggest different photons from the same event traveled at slightly different speeds despite all being electromagnetic radiation. The speed variations correlate with photon energy levels, indicating that light speed may depend on frequency in ways that violate the fundamental principle of relativity, requiring all electromagnetic radiation to travel at exactly the same velocity. The variable light speed measurements have been confirmed across multiple independent observations and different types of astronomical events. The consistency of the variations suggests that space itself may influence photon propagation speeds through mechanisms that conventional physics cannot accommodate. Laboratory experiments have demonstrated apparent faster-than-light information transfer through quantum entanglement effects. When paired particles are separated and one is measured, the other instantly assumes correlated properties, regardless of the distance between them. This spooky action at a distance appears to violate light speed limitations on information transfer. Physicists argue that quantum entanglement cannot transmit usable information faster than light because the measurement outcomes remain random and unpredictable. However, recent experiments suggest that subtle correlations in entangled systems might allow information transfer through channels that bypass conventional electromagnetic signaling. Deep space observations reveal cosmic structures that appear too large to have formed within the age of the universe if matter could only move and interact at light speed or below. These structures require coordination across regions of space so vast that light should not have had time to travel between them since the Big Bang. The oversized cosmic structures suggest either that the universe is much older than current models indicate, or that matter and energy can communicate and organize themselves through faster-than-light mechanisms during cosmic evolution. The structures exist regardless of theoretical limitations, forcing physicists to question fundamental assumptions about cosmic history. Some astronomical phenomena demonstrate what appear to be synchronized responses to events before light from those events could have reached them. Distant supernovae trigger correlated responses in nearby star systems, with timing that suggests the responses began before the supernova light arrived, violating basic causality principles. The anticipatory responses might indicate that space contains precognitive information channels that allow future events to influence past conditions. These temporal feedback loops would require fundamental revisions to our understanding of causality and time's arrow, suggesting that space operates according to rules far stranger than current physics accommodates. Certain cosmic ray events produce particle cascades that include exotic particles traveling faster than light speed in local reference frames. The superluminal particles violate special relativity's fundamental prohibition against faster-than-light motion, yet they appear consistently in high-energy cosmic ray showers, observed by multiple independent detection facilities. The faster-than-light particles may indicate that relativity's speed limit applies only to normal matter and energy, while exotic particles can exceed it under specific conditions. Space itself might support multiple different speed limits for different types of matter, allowing phenomena that would be impossible under standard relativistic constraints. But light speed anomalies represent just one category of space's impossible characteristics. Magnetism extends throughout space in ways that defy conventional electromagnetic theory. Planets, stars, and galaxies all generate magnetic fields through dynamo processes involving rotation and electrically conductive fluids. And these magnetic fields should decline with distance according to predictable mathematical relationships. However, deep space observations reveal magnetic fields that maintain coherent structure across vastly larger distances than conventional theory predicts possible. Intergalactic magnetic fields span millions of light years, while showing organized patterns that suggest coordination rather than random field generation from distributed sources. The large-scale magnetic structures demonstrate field strengths and coherence lengths that require sustained electric currents flowing across galactic distances. No known natural process can maintain such currents for the billions of years necessary to create the observed magnetic patterns. The currents appear to be actively driven by mechanisms we cannot detect, Some cosmic magnetic fields show reversal patterns that occur simultaneously across vast regions of space, despite the lack of any apparent communication mechanism between distant field-generating sources. The synchronized reversals suggest that cosmic magnetism may be controlled by organizing principles that operate on scales far exceeding individual stars or galaxies. Spacecraft instruments have detected magnetic structures in apparently empty interstellar space that exist without any corresponding mass or energy source. These free-floating magnetic fields maintain stable configurations for extended periods before dissipating suddenly, suggesting they may be artificially created and maintained. The sourceless magnetic fields demonstrate properties that suggest they serve specific functions related to cosmic organization and structure formation. The fields appear positioned to guide the motion of charged particles and plasma clouds, channeling material flows along pathways that determine where and how new stars and planetary systems form. Earth's magnetic field itself demonstrates anomalies that conventional geophysics cannot adequately explain. The field's strength varies by factors that exceed what should be possible given the planet's rotation rate and core composition. Some variations occur too rapidly to result from changes in the core's fluid motions. Recent satellite measurements reveal that Earth's magnetic field contains components that appear to originate from sources outside the planet entirely. These external field contributions show patterns that suggest they may be artificially generated and precisely calibrated to augment Earth's natural field, for purposes we can only speculate about. The Sun's magnetic field demonstrates complexity that far exceeds what stellar physics predicts should be possible. The solar magnetic structure includes features that appear and disappear according to cycles that correlate with planetary positions in ways that gravitational interactions cannot explain. The correlations suggest that solar magnetism may be influenced by mechanisms beyond conventional electromagnetic processes. Some solar magnetic events appear to anticipate changes in the interplanetary environment before those changes occur, demonstrating apparent precognition that violates causality principles. The Sun's magnetic field responds to approaching cosmic ray events and solar wind variations before they arrive, suggesting access to information channels that operate faster than light speed. Magnetic storms on Earth correlate with solar activity, but also show correlations with deep space events that should have no physical mechanism for influencing terrestrial magnetism. Distant supernova explosions and gamma-ray bursts trigger measurable responses in Earth's magnetic field, with timing that suggests faster than light influence propagation. The magnetic mysteries suggest that space contains electromagnetic organizing principles that operate independently of conventional electromagnetic theory. These principles might represent fundamental forces we haven't discovered, governing cosmic evolution through mechanisms that remain invisible to current detection methods. But magnetic anomalies represent only a small fraction of space's truly bizarre properties. Vacuum energy permeates all of space, according to quantum field theory, representing the zero-point energy of quantum fields that exists even in apparently empty space. This vacuum energy should exert gravitational effects and contribute to the energy density of the universe, influencing cosmic expansion and structure formation. Theoretical calculations of vacuum energy density produce results that exceed observational limits by approximately 120 orders of magnitude, representing what physicists call the worst theoretical prediction in the history of science. The catastrophic mismatch between theory and observation suggests fundamental gaps in our understanding of quantum mechanics, gravity, or both. Some regions of space demonstrate vacuum energy effects that vary from location to location, despite quantum field theory, predicting that vacuum energy should be perfectly uniform throughout the universe. However, the variations suggest that space's quantum properties may be actively managed by mechanisms that regulate energy density on cosmic scales. The vacuum energy variations correlate with the positions of galaxies and galaxy clusters in ways that suggest the variations may be deliberately positioned to influence cosmic structure formation. The correlations appear too precise to result from random quantum fluctuations, indicating possible engineering of the quantum vacuum itself. Deep space observations reveal regions where vacuum energy appears to be extracted and utilized by unknown processes. These energy extraction zones show reduced vacuum energy density, surrounded by structures that suggest mechanisms for capturing and redirecting the extracted energy towards specific purposes. The vacuum energy extraction indicates that civilizations might exist that have mastered technologies allowing them to tap into the quantum vacuum as an unlimited energy source. The energy requirements for such extraction exceed anything current physics suggests would be possible. Yet the observational evidence indicates the extraction is occurring on cosmologically significant scales. Laboratory experiments have demonstrated that vacuum energy can be manipulated through precise arrangement of reflective surfaces, creating measurable forces between objects separated by vacuum. The Casimir effect proves that vacuum energy is real and can be controlled, at least on microscopic scales. Recent experiments suggest that vacuum energy manipulation might be scalable to macroscopic dimensions, using materials and geometries that current technology cannot produce. The scaling relationships indicate that sufficiently advanced engineering could create vacuum energy effects powerful enough to influence spacecraft propulsion or planetary-scale energy generation. Some cosmic phenomena demonstrate energy outputs that far exceed what any known fusion or matter-antimatter reactions could produce. These ultra-high energy events might be powered by vacuum energy extraction processes that operate on scales far beyond current human technological capabilities. The vacuum energy mysteries suggest that space itself contains essentially unlimited power that could be accessed by civilizations with sufficient technological sophistication. The universe may be far more energetically rich than conventional astrophysics recognizes, with most cosmic energy existing in forms we haven't learned to detect or utilize. But vacuum energy represents only one aspect of space's hidden resource abundance. Dark matter supposedly comprises approximately 85% of all matter in the universe, providing the gravitational glue that holds galaxies together and determines the large-scale structure of the cosmos. Yet decades of intensive searching have failed to detect a single dark matter particle, despite increasingly sophisticated experiments specifically designed to find them. The absence of direct detection combined with the extreme fine-tuning required to make dark matter models work suggests that dark matter may not exist as physical particles at all. The gravitational effects attributed to dark matter might instead result from modifications to gravity itself, or from influences originating in dimensions beyond the familiar three of space. Some galaxies show gravitational effects consistent with dark matter, while others demonstrate gravitational properties that cannot be explained through dark matter models, regardless of how much invisible mass is added. The inconsistency suggests that whatever causes the gravitational anomalies, it operates selectively rather than uniformly throughout the universe. Recent observations reveal that supposed dark matter distributions sometimes correlate precisely with the visible matter distributions they're meant to explain, showing relationships that should not exist if dark matter and normal matter interact only through gravity. The correlation suggests that dark matter effects may be intimately connected to normal matter through mechanisms beyond gravitational attraction. Some cosmic structures demonstrate gravitational effects that vary over time, despite containing no visible changes in mass distribution. The time-varying gravity suggests that dark matter either moves in coordinated patterns or that the gravitational effects result from something other than particle mass. Alternative theories propose that dark matter effects result from gravitational influences leaking into our three-dimensional space from higher dimensions, where mass exists but remains invisible to conventional detection. This brain-world scenario would explain why dark matter has never been directly detected while still producing observable gravitational effects. Other models suggest that dark matter represents a form of matter that exists in a parallel reality, overlapping our own space, but interacting with our matter only through gravity. This shadow matter would be literally invisible and undetectable through any means except its gravitational influence on visible matter. The most intriguing possibility suggests that dark matter effects result from active gravitational manipulation by advanced civilizations, using technologies that allow them to generate gravitational fields without corresponding mass. The civilization hypothesis would explain why dark matter distributions sometimes appear too precisely tuned to be natural phenomena. Some dark matter observations show patterns that suggest deliberate positioning to achieve specific gravitational effects. The patterns include symmetric arrangements and geometric configurations that appear designed rather than randomly distributed, and indicating possible artificial origin for at least some supposed dark matter effects. The dark matter mystery extends throughout space, touching every galaxy and galaxy cluster in the observable universe. Whatever dark matter truly represents, it demonstrates that the universe contains far more mystery than current physics can explain. But dark matter represents only one of multiple invisible components, supposedly pervading space. Dark energy supposedly comprises approximately 68% of the total energy density of the universe, driving cosmic expansion to accelerate rather than slow down as gravity should require. The discovery of cosmic acceleration won the 2011 Nobel Prize in Physics, while simultaneously revealing that we don't understand what most of the universe is made of. Dark energy demonstrates properties that seem perfectly calibrated to produce the cosmic expansion rate we observe. The calibration appears too precise to result from random chance, suggesting either extreme cosmic luck or underlying principles that determine dark energy's characteristics with extraordinary precision. Some cosmological observations suggest that dark energy's strength may vary across different regions of the universe, creating a landscape of varying expansion rates that influence cosmic structure on the largest scales. The variations would indicate that dark energy is not truly a universal constant, but rather something that can be modified by local conditions. Alternative theories propose that dark energy effects result from modifications to general relativity that become significant only at cosmological scales. These modified gravity theories eliminate the need for mysterious invisible energy, while explaining cosmic acceleration through novel gravitational phenomena. Other models suggest that dark energy represents quantum vacuum effects that somehow avoid the catastrophic theoretical predictions that plague standard vacuum energy calculations. The models require extremely precise fine-tuning that appears suspiciously designed to produce the exact cosmic expansion rate we observe. The most radical proposals suggest that dark energy effects result from our universe existing as part of a multiverse, where our cosmic expansion is influenced by interactions with parallel universes we cannot observe directly. The multiverse interactions would manifest as apparent dark energy driving expansion from within our observable space. Some observations suggest that dark energy's strength may be changing over cosmic time, producing expansion rates that varied throughout universal history. The time-varying dark energy would require fundamental revisions to cosmological models, while potentially explaining various cosmic anomalies that standard models struggle to accommodate. Recent measurements indicate possible spatial variations in dark energy density that correlate with the positions of extremely large cosmic structures. The correlations suggest that dark energy may interact with normal matter and energy through mechanisms beyond the simple uniform pressure that standard cosmological models assume.